We are often interested to analyze the deformations and strains caused in any mechanical system subjected to any kind of force fields. Strain gauges have found its extensive use in a recent past for this purpose. We know resistance varies with length of any material, and this principle has been used for this experiment, and using this principle the strain gauges are used to determine even the micro strains present in the system. The signals of the resistance changes are obtained you connecting the strain gauge in a quarter whetstone breech for this experiment, and pitch recorders are used, which directly transforms the resistance changes into the presence of the micro strains into the system for this experiment.
So we have an aluminum beam, and what we're going to do is we're going to put one strain gauge on it and measure the strain in the axial direction of the beam. And when we look at this, there's been a hole that's been drilled into one end. This will be the loading end of the beam. So we're going to clamp it on the opposite end with a C-clamp. So we want a strain gauge to be somewhere around in this area. So we're going to prep the surface to put a strain gauge on it. Now, I always recommend following the instructions fairly closely, and the M-Bond 200, the adhesive that we're going to use, comes with some nice instructions. We'll need several supplies, but we'll talk about those as we go through them. And so step 1 says thoroughly degrease the gauging area with a solvent such as CSM degreaser or isopropyl alcohol. All degreasing should be done with uncontaminated solvents, thus the use of one-way containers such as aerosol cans is highly advised. So if you use alcohol, you don't want to swab the alcohol and put it into the container of alcohol. You want to have it in a one-way situation. We're going to need some gauze pads, and this is the degreaser. Now this is a little dirty, so there might be a little bit of grease on this one. So I'm just going to spray this on. So I'm going to just spray this on and get some of that off. Now, when you go to wipe it down, kind of wad this up, put it in the middle of where you want your gauge to be, and wipe it to one side, and wipe it to another side. We don't want to reuse these, just throw it away when you're done. So I'll do this a couple times to get some of that grease and debris off. So I'm turning this cotton each time I'm wiping it. Alright, so the next step says we're going to do a preliminary dry braid with 220 or 320 grit silicon carbide paper. So I take a look at my sandpaper, and this one looks like it's the 220 grit. The 220 grit is kind of a coarse sandpaper. So I'm just going to tear a little bit of it off. And in a circular motion, I'm just going to abrade this. We want to avoid making longitudinal scratches on this bar, as it may influence the strain readings. And this is an extrusion, so there already is some kind of longitudinal scratches. We want to try to knock some of those down. Final braiding is done by using a 320 grit silicon carbide paper on surfaces thoroughly wetted with Imprep A conditioner. So there are two chemicals. One with the little red top is the Imprep conditioner A. It's slightly acidic. And then the other one is the neutralizer. It's important to get the order of these correct. So we're going to use 320, which is a little bit finer. and we're going to thoroughly wet the surfaces. That just means put this on here. Now you see I have a pad down to kind of collect some of the runoff chemicals. This is slightly acidic. If you have sensitive skin, you may want to wear gloves while you do this process. So a wet a braid just means keep that on there while you take the sandpaper and abrade the surface. Now you don't want to let this dry on your specimen, so every once in a while kind of clean that up a little bit, and if you need, go ahead and wipe it. You don't want the contaminants to dry on it. Again, fold it up, wipe one way and then the other. And this is followed by wiping dry with a gauze sponge. Repeat this wet abrading process with 400 grit silicon carbide paper. So we're going to do the same thing now with an even finer grit sandpaper. We're going to use an adhesive, and anytime you use an adhesive, surface preparation is really important. You're going to get the glue to stick. On some materials like steels, you may have to use a little bit more aggressive ways to get rust off of the surface or something like that. If you're going to put more than one strain gauge, you should think about this at this stage and make sure that you've prepared enough of the surface. And if you notice, the bottom surface may get a little bit contaminated too, so you have to be careful not to cross-contaminate the surfaces if you have gauges on the top and bottom. Now this step, it says use a 4H pencil on aluminum or a ballpoint pen on steel to burnish alignment marks. I'm not going to do that step, but if we wanted to, since I can pretty well tell what the axial direction is, but if we wanted to, we could put an alignment mark that goes down the axis of this with a pen or a pencil. We would rub off that ink, get it clean, and by burnishing, what you're doing is you're taking all the little bumps and hills and flattening them out, so you'll still be able to see where that burnish line is at. Repeatedly apply Imprep Conditioner A and scrub with a cotton tip applicator until a clean tip is no longer discolored. So I have some cotton tip applicators. I'm going to put some more of the conditioner on here, and when you go to grasp the applicator, take your thumb, kind of hold it down and put some pressure on it, and you want to get it kind of close in there, and you might see that there's a little bit of dirt, a little bit of oxide that's on that tip. So we want to do this until it's relatively clean. Sometimes with aluminum you can't ever get it completely gone, but you can get pretty close. So that looks pretty good. So now I'm going to make sure that it's nice and dry, again with my cotton. One way and then the other. And I want to make sure nothing will drip on it, so I'm going to try to clean up the bottom as well. It needs to be thoroughly dry. Right now, the next step says, now apply a liberal amount of Imprep Neutralizer 5A and scrub with a cotton tip applicator. So this would be with the blue top. Open that up and put a little bit on the same spot that we've been working on, and then just use our cotton tip applicator. By doing this step, we're returning the surface to a neutral pH. Now, while we're doing this, the chemicals that we use have expiration dates on them. If you're working for a company, you should probably make sure that you use chemicals that are in date to achieve the best performance. Sometimes in the university lab setting, I use chemicals that are a little bit out of date. If I haven't used them in a little while, it's probably okay. But on the job, you may find that labor costs are fairly expensive, and so you want to make sure you use the best chemicals so you don't run into any problems. So now I have it clean and dry. Alright, now at this point I'm going to take away this pad and clean the surface up and use a new pad. Okay, so we're just following our instructions along. The next step says to use tweezers to remove the gauge from the transparent envelope. Place the gauge bonding side down on a chemically clean glass plate or gauge box surface. So what they mean by that is here's a gauge box. The strain gauges typically don't come in these anymore, but I have some of these laying around. You can use a glass plate to lay out your gauge as well. Now there's two sides to this box. If you have one of these, one side has this writing on it, the other side doesn't. Use the side that does not have the writing. And we need to make sure that it's chemically clean, so we're going to kind of repeat some of these processes. We're going to use the conditioner scrub that in there. Dry it off. So we don't want any dust or contaminants or grease where we're trying to lay out our gauge. I've used the conditioner, now I need to use the neutralizer. The next thing we need to do is to find the gauge that we're going to use, and we need to understand the gauge factor. It's 2.095, and here it has a transfer sensitivity of 0.6%. These are EA 13 gauges. 13 stands for the coefficient of thermal expansion for aluminum, which is what we want to use, so it's a self-temperature compensating gauge. I'm going to get in my toolbox and pull out one of these little gauges. Come in a little package. I'm going to flip that open. And you can see it has a shiny side and it has a side that's not shiny. We want to make sure that the shiny side is up. So we'll place that on there. If there's a little bit of static electricity, it might jump around a little bit. We're just going to line that up. Then we're going to look at our instructions. If we need a solder terminal, it would be time to place that in line with that. And then it says place a 4 to 6 inch piece of micro measurements tape over the gauge and terminal if you have one. Take care to center the gauge on the tape. Carefully lift the edges at a shallow angle, about 45 degrees to the surface of the specimen, bringing the gauge up with the tape as illustrated above. So we're going to use this cellophane type tape. And if this has been in the lab for a little while, this surface may be kind of coated with dust. So I usually like to take that, unravel it a little bit beyond that point, and throw the initial portion of the tape away. And then pull a piece off to use to cover the gauge up with. So here we're going to be a little careful. We'll try to center this up a little. So I'm going to bring this straight down over the top of it and flatten it out. Kind of get the air bubbles out. And then at a 45-degree angle or so, I'm going to take this and I'm going to lift it off of that box. And the gauge comes right with it. I'm going to take my specimen. I have my surface where I just cleaned. I'm going to come over here and I'm going to put the gauge so that it's kind of aligned with the axial direction of the bar. Now if you're not happy with the placement at this point, we haven't glued it down yet, so we can pick it up and we can reposition it. Now I didn't draw a line on that to begin with, so I am going to try to eyeball it. That looks like it's pretty much down the axis of the bar. So here's the grid pattern. We do want the grid pattern to be down the axial direction of the bar. On the right of the grid pattern are the solder terminals. Now something to also keep in mind is that we're going to clamp this on this end, so we do want to make sure that the wires have a place to go without running into the C-clamp. I think we're good. All right. Now we're going to go to our next step. We've positioned the gauge. We're going to lift the tape back up, and we're going to put a little bit of catalyst on it. We're using M-Bond 200 for this installation, and it's like a surgical super glue. There are other systems like an epoxy system that you can use. But this is good for quick installations. Catalyst is this blue material, and it's important not to use too much catalyst. When you unscrew the top of this, there's a little brush. Take that brush and take it side to side several times to get some of the excess catalyst off. And when you place this brush, don't place it directly on the back surface of the gauge. Take it and place it on the tape away from the gauge. So for example, up here. And then maintaining contact, take that gauge, take that brush and move it on the back surface of the gauge. And then away from the gauge, lift it up. That'll produce a nice thin uniform coat of catalyst. Now move the brush to the adjacent side of the tape before lifting it away from the surface. Allow the catalyst to dry at least 1 minute under normal ambient conditions of 75 degrees Fahrenheit or 24 degrees C and 30 to 65% relative humidity. So we need to let that just dry for about a minute. And while that's going on, let's read the next steps, because the next steps are important to be done quickly. The next step is to find our glue, and this glue, you might be able to see that it's nice and runny. That's good. If your glue is very thick, you probably need new glue. This is the M-Bond 200. We're going to put a little drop of glue where that tape line is. We'll take a gauze sponge, and we're going to wipe that forward with the glue going underneath of it, and then we're going to immediately put our thumb on the gauge so that the heat from our thumb helps speed the reaction of the catalyst. So these next steps need to be done all in about 15 or 20 seconds. So we'll go through those pretty quickly. So I think we still have a few seconds to wait for the catalyst to dry. So while that's drying, we're just going to make sure that our lids are back on our chemicals and that we have everything we need for the next step. So now I'm going to take and I'm going to get the lid off of my Inbond 200. It doesn't take much, it takes only about a drop. I'll put it right at the edge of that tape line. I'm going to take my gauze and I'm going to bring this forward, and that glue is going underneath my gauge. And I'm going to keep wiping it forward, and then the excess glue should be wiped up with this gauze. So I'm going to press down one more time to make sure I have all the air bubbles out of it. Then I'm going to take my thumb and I'm just going to hold it in position. The pressure should be held for at least 1 minute in low humidity conditions, or if the ambient temperature is below 70 degrees F, this pressure application time may have to be extended to several minutes. And so I'll keep my thumb here for a little bit, but we may want to wait a little bit. It's kind of cold in the lab today, so we may wait for a minute or two or several minutes, and then pull the tape back off and to see if our gauge has stuck to our surface. Particularly on metal parts, that the heat can be conducted away pretty quickly. So if it's a cold day with a piece of metal, you may want to wait even overnight to get a good bond with your material. Now I'm going to set this aside and let's prep another specimen. This is a soda can. We're going to prep this to put a strain gauge rosette on it. So in this experiment, we're going to measure the pressure that's in a soda can. This is a nice clean surface, so we can skip some of the previous steps that we talked about degreasing and everything. It's really a pretty nice surface. We are going to use some sandpaper, and we're going to get some of this paint off of it. But we're going to go right to the 400 grit. We're going to modify our procedure just a little bit. Now the thing about the soda can is that we do not want to go very deep with our sandpaper. So just going to abrade it a little bit here. Now this is a laboratory specimen. Do not drink the soda after we go through this. You don't want to get a chance of having any chemicals get into your mouth. Okay, so that's a little dry braid. We're going to go and we're going to use the conditioner and do a wet braid. And on this one, we're going to put a strain gauge rosette. So we might need a little bit larger area. So if we put a strain gauge rosette in there, it probably would be about the right size. So wipe it down. Try to get some of the sides dry so it doesn't contaminate the surface. And then we'll go to the cotton swab, again with the conditioner. I don't want it to dry, so I'm continuing to wet it. And then we'll dry it off. Now we'll go to our neutralizer. And pushing down fairly firmly on the cotton swab, we're just going to swab that neutralizer in, that surface that we've prepared. We're going to dry our surface off. Here we have our box that we've already cleaned. I'm going to lay our gauge out. And we do want to note the gauge resistance, the gauge factor, and the transfer sensitivities for each of these three gauges in the rosette. Now with the strain gauge rosette, you have three gauges on the same plastic backing. And this is a 0, 45, 90 degree strain gauge rosette. So we'll lay that out on this plastic box. Strain gauges are single-use items, these electrical resistance strain gauges, and so we can't use them again. So if you mess up, then you just have to start over. Got my tape. I'm going to put it down over the gauge surface. Of course, the shiny side is up. And flatten it out. I'm going to lift it up with a shallow angle. And I'm going to bring it over here to the can. Now, in lab, I probably instructed you to put this on so that you have a skew angle from the axis of the strain gauge rosette to the axis of the can. But what we're going to do today is we're going to try to line this up so that one gauge is in the hoop direction and one gauge is in the axial direction. That'll make our calculation of the pressures a little bit easier. Now, it may not be perfect, and you can take a look at your strain results and find the principal axes of strain and see if you can detect any off-axis angle from the measurements. Okay, so we'll go through the same process. We're going to peel this back. We're going to put a little bit of catalyst on the back and make sure that you don't have very much catalyst. And take the brush, put it on away from the gauge, and then paint the back of the gauge surface, and then lift it up away from the gauge, and then allow that to dry for at least a minute. Now, at the same time, as I'm cleaning things up a little bit, I do have my soldering iron turned on, and we'll do some soldering here in just a little bit. Without trying to rush it too much, let's go ahead and put a little glue on it. We're going to do the same procedure. We'll put a drop of glue. Now, this drop may be a little bit bigger than the previous one since we have kind of a larger gauge pattern. In fact, if you have really big gauges, you may use 2 pieces of tape, one over the edge of the other, in order to make a kind of a larger tape. I have my glue on that surface. I got my gauze. Again, I'm going to wipe this forward. I want to pay attention that my glue does go underneath my gauge. So I'm bringing this forward. Now, this is basically like a surgical glue, so it can stick your fingers together if it dries on your fingers. It will eventually come off. But it is some pretty strong glue. So now I'm going to make sure that my thumb is on top of that gauge for about a minute to try to help speed up that reaction. Make sure the lid is back on your glue before you put it on. So while I'm holding this here, we'll just talk a little bit about strain gauges in general. Strain gauges are electrical resistors. They're based on the principle that as a wire stretches, its resistance changes. Small change in resistance, but that can be measured with something called a Wheatstone bridge type circuitry. I'm going to set this one aside, and I'm going to check our other specimen. And you want to make sure that there's no soft spots even in the tape around where the gauge is at, because that may indicate that the glue is not dry. Now, here's the moment of truth. We're going to take and we're going to peel this tape off at a very sharp angle, and if everything goes well, the gauge will stay stuck to the aluminum beam and the tape won't be there anymore. So by a steep angle, what I mean is it's kind of pulling it back over itself very steeply. Okay. And so the gauge did stay, and that's great. So it should be well bonded to that aluminum beam. Now there's different styles of strain gauges you could purchase. You can purchase some with pre-attached lead wires. You can purchase some that have little plastic over the gauge pattern. The gauges that I typically buy for the lab are called open-faced gauges, and so we're going to have to protect the gauge while we do our soldering. So we're going to go to our next type of tape, the drafting tape. Again, throw away the first little bit that's been sitting around, collecting dust. And we're going to cover the gauge itself up and leave the soldering tabs exposed. Now once this tape is on here, you don't want to just rip it off. We're going to have to use something called rosin solvent to help loosen up this tape. So if you don't like the way where it is right now, don't just pull it up. Use the rosin solvent to help you. Okay. Now there's a couple things we need to do before we get our wires soldered to this. We need to prepare a lead wire, and we need to what are called tinning the tips of tinning these solder terminals that are on here. Now I do have part of a lead wire prepared. We're going to use a 3-wire quarter bridge setup, and in this setup 3 wires go to the instrument, the black, white, and red, and 2 wires get bonded together and go to the gauge. I always like to take and tie the white and the black together, and then the red one off by itself. These are electrical resistors. It doesn't matter which way you hook them up. But we do want to have a fairly short lead wire. So I'm going to take and I'm going to clip this back quite a bit. In fact, I may end up re-stripping the one end a little bit. But we want maybe a millimeter or maybe even less showing, because we want to make sure that the wire doesn't touch the aluminum beam. It has to stay on top of the plastic of the strain gauge. I'll trim these back just a little bit. So let's go over to our soldering iron. What I have is it's called a 361 solder. It's in this container, but it has a eutectic point of 361 degrees Fahrenheit. So we need to make sure our soldering iron is set to 361. You want to make sure you use a really good soldering iron. These soldering irons cost, at the time of this video, maybe close to $2,000. So they're fairly expensive. It's not just a soldering station that you might get at a discount store. They're kind of expensive. So proper use of a soldering iron, we have it heated up and warmed up. This is some flux. I'm going to dip it in here, and I'm going to wipe this carefully without burning yourself on a piece of this cotton gauze to kind of clean the tip. And as soon as you clean the tip, you want to take some of the solder and you want to have it melt, and you want to keep a little bit of solder ball on the end of that tip. Now what I want to do to create a little solder on these terminals is I'm going to take this solder, I'm going to put it on there, and then I'm going to push into it, and I'm going to leave it there for maybe 3 to 5 seconds, and then I want to lift the solder and the iron away at the same time. I'll show you hopefully a good one, and then I'll try to make a bad one, and we'll see how it goes. I'm holding it on there, pushing the solder in, and lifting it up. These particular gauges I have are kind of old, so I may have to go back and clean the terminals a little bit to make sure that we get a nice surface. Yeah, I'm going to have to clean these up. Now, to help clean these up, if you have some old gauges, you're going to use a cut and swab and a little bit of this rosin solvent. Chances are you tried to solder it and it didn't stick. So I'm going to clean it up a little bit, this rosin solvent, and then take the cut and swab, just kind of gently abrade the solder terminal. If the gauges are really old, there's probably some oxide that's formed on those terminals. And these gauges in this lab, they may be 20 or 30 years old at this point. Just depends on what project I've done or my predecessors have done in this lab. Let's see if I can get it the solder to stick on that now. So there it is, there's a tiny solder bubble. That's enough. This solder is a lead tin solder, and it's got a little rosin core, so it does put off a little bit of smoke. Leads of the wire as well. So to do that, I'm going to set the solder here. We want to transfer the solder, the liquid solder, onto the wire, the exposed wire. So I'm just going to bring it through as it heats up. That'll keep your wires from fraying as you cut it or put it in the instrumentation. Okay, so again, I want to make sure that's nice and short. I like to say this is the part where it helps if you have three hands, because we need to solder this and get it in the right spot. Now to help us as our third hand, we're going to use a little bit of tape. And we're going to take this tape, we're going to put it on this wire, and we want to position the wire in such a way that it puts a little downward force onto that little solder bubble. So we're going to take and we're going to bend the wire just a little bit. We're going to take that and then position it just where we want. And so now it's sitting on that solder bubble, which is a little bit of downward pressure into it. When that goes liquid, then that should help push that wire down into that solder. We should have a connection. Now we're not going to lift that up, we're going to leave it there. We're going to do the same thing to the black and the white pair that are twisted together. Now, before we go any further, we ought to check to make sure that we have the right resistance that we want. Go over to our multimeter and put it on ohms. And we have these 3 wires. The black and the white are bonded together. So if we go between the black and the red and the white, we should get 120 ohms if we have a good connection. Because it's a 120 ohm gauge. So that looks good. And that looks good, so we have a good connection. All right. Now we're going to come back over here. We're going to use the rosin solvent. We're going to take that tape off the gauge. We go ahead and leave the tape on the wires. But when you do this, you want to get under the one corner, and you want to just let this eat away the mastic, maybe a little slight upward pressure. But you want to let the rosin solvent do the work so you don't tear up your gauge. Now the rosin is slightly acidic, so we don't want to leave that rosin on there. Sometimes you can see this, it makes little rings down where you soldered it. So you want to just take this brush and gently let that solvent eat away the rosin so that you don't have that acidic material sitting on your gauge. Eventually that'll cause problems if you intend to have this on for more than just a little bit of time. That rosin solvent's fairly volatile. It will evaporate fairly quickly, but you can take and you can dab the surface of the gauge with some cotton. Now at this point we can put some protective coating on this, or we can leave it bare. If we put a protective coating on it, I've had these gauge installations last several years, 10 years even. If we don't put the protective coating on it, it may not last anywhere near as long. So it just depends on what you want to do. I use M-Coat A typically, and it's kind of like some kind of plastic coating. It comes out liquid, and then it dries into kind of a hard.
For setting up the beam for the experimental analysis of the strains, we need to set up the beam, and for that we need to clamp it as we are doing for the fixed boundary condition. As you can see, it is clamped with a C-clamp in one end, and it's been loaded in the other point by a load hanger, and we will be applying the loads over this load hanger and record the strains in this P3 indicator and recorder. So before the start of the experiment, the beam should be connected for passing the signals into one of the inputs of this P3 recorder, and as you can see, the red wire is connected into the P+, and the white one is connected into the S-, and the black one is connected into the D120 of the first input channel. Okay, so now we'll start our experiment of analysis of strain for application of loads. For that we're using that P3 strain indicator and recorder. First we need to turn on the machine by putting the power button. We're starting on, and then we need to calibrate for these loading conditions. As just shown just now, this loading condition and clamping are set. And so we'll go forward with the calibration by this balance button. We should press this balance button. Now we should put it once again, and it will auto balance. As we can see, there are no connections there in the second, third, and the fourth input, so it will balance only the first input. And for recording, I have to press it once again. We have to save the settings. It will ask you whether you want to save the settings. You should press the record button for saving all the settings. So now, as you can see, there is 0 micro strain. There is no strains are there in the beam for the loading conditions and the clamps. That is, it's been perfectly calibrated. Now we'll start with our experiment by application of loads. First, we are applying the 1 pound load. As you can see here, it's 1 pound. So we will note the micro strain recording over here for the application of this load. So it's 83 microstrains. Now we will try the same for the 2 pound loads. We will first release this and then add the 2 pound load. This is a 2 pound load. Microstrain is now 166. It should be linear because we have just started the experiment, and it should be linearly elastic in this zone. Now we will go for the 3 pound loads. We are adding 1 load with the 2 pound to get to the 3 pound load, and the microstrain is now 248 microstrains. Now finally we will again measure for the 4 pound load. We will release this 1 pound and add the 2 pound load with the 2 pound load to add it to 4 pound loads, and it sums up to the microstrain of 330. We should record all the microstrains for the corresponding loadings. And finally, we will go for the 5 pound loading by adding this 1 pound with this couple of 2 pound loadings. Sums up to 5 pound loading, and the result is, as we can see, it's fluctuating, but it may stand up to 413 microstrains, which should be recorded, and that's it. Okay, so as we have got the microstrains in the experiment, we have plotted that with the loads, and we have got this kind of experimental plot, which is shown in the green plot. And after performing an experiment, everybody should measure the accuracy of the experiment by converging it, by checking the convergence with the theoretical plot. And as we have shown in this plot, that the convergence is well maintained, and that should be checked after any experiment. As we have seen, the experimental and the theoretical plots pretty much converged. It can be concluded that the experimental approach using the strain gauge is quite reliable approach, and this is a pretty much handy method, and it can be performed for getting a good and almost accurate idea of behavior of the strains and deformations in any systems. The care should be taken while setting up the system and fixing the boundary condition, because the partial fixity might cause unexpected deformations for the large-scale structures. Anyway, nevertheless, the method is quite popular nowadays, and it's used extensively in many real-time structures in the recent past.